Hey, good evening, everybody. Welcome to Meteorology Lab here on Father's Day Sunday evening. We are getting the fire hose of tropical weather here in Texas, and you can see that on that opening clip. Lots of vertical cumulus, and that's a look off to the east there. And at this time, a lot of the convection is starting to shut down. Let me switch over to the radar, and you can get a look at that here. There's what things look like across most of Texas. Just a few stray showers around the Hearn area, just north of College Station, and everything is starting to shut down. So let me give you a look at the satellite. And while we're on it, you can let me know how the audio is sounding. I didn't have a chance to check that out. All right, here it is. There's a look at what's happening there in Texas in our home area. And of course, we will look at the rest of the country. And you can see earlier today, there's all those lines of showers coming in. This is kind of a complex sea breeze front with a lot of outflow boundaries. And this is part of the tropical surge coming in off the Gulf. And this is more active than we typically see in June. So as the evening goes on, lots of showers there. And one thing that's very telling that you should kind of pay attention to when you're looking at model output, or not model output, getting ahead of myself, the satellite, is the anvils. See that direction there? These anvils are streaming from northeast to southwest. And this is actually a little different from the anvils that we have over the Panhandle. Those are going to the north. So what this is doing is it's painting out an anticyclonic flow. And that's indicating some high pressure aloft over North Texas and Oklahoma, and possibly a bit of a ridge kind of coming in like that right there. Yeah, so we're doing the full-on John Madden, marking up the video there, but let me run this video one more time, and you can see the difference. Here's those anvils in the Houston area streaming to the southwest, and around Amarillo and Canadian, they're streaming to the north. So there's actually a lot that satellite can tell you, just looking at motions, textures, and patterns. Surface chart for this evening. The greens, as usual, are the dew points, and you can see they've come up pretty significantly across much of Texas. Lots of stations in the low to mid 70s, and even out in West Texas where they've been bone dry, dew points in the 50s, those have come up to near 70. And along with that, the temperatures have come down quite a bit. The highest readings we're seeing about 91 in the Abilene area. Going up to the northern plains, it's been pretty quiet in Oklahoma and Kansas today. North winds bringing in moisture, and we'll show you a little bit later why there hasn't been much going on in that region. But as we go north into Nebraska, Colorado, Wyoming, there is yet another front coming southward. Temperatures in the 50s at this hour. There's all that cool north wind coming in from North Dakota into Nebraska. And this time of year, a boundary like this is very significant. That can be a major instigator of thunderstorms. As we go up even further north, we can pick up the active cold front right there and what looks like a outflow boundary in the Minneapolis area. So why don't we take the radar up north? Let me switch over to that one, to Minneapolis. And we'll get a closer look at the activity in that area. So this will take probably a moment to come up. In the meantime, we can look at the SPC products. Lots of thunderstorm activity all the way from northern Wisconsin out to the Minneapolis area and over to northern Nebraska. And behind there, you can see cold air advection, some elevated showers in that area, and it's producing a lot of virga. It's precip not really hitting the ground because of the dry infusion of cold air coming in the lower levels. And then there's the SPC forecast right there. Just a slight risk, almost directly outlines the front. Same areas there, Wisconsin down to Nebraska, and a couple tornado warnings or tornado watches, where we have some of the better backing of the low-level wind flow. And there's the radar there for the Minneapolis area. A lot of the storms, they look kind of disorganized. And you can really tell that when you zoom in on these cells. The cores are pretty well centered within the precip areas right there, and only the tail ends are really giving us some activity there. So let me switch over to the velocity, and this will kind of show us what's going on there. This is showing lots of outbound precip rapidly moving to the east there, and we could subtract out the motion. We'll set a vector here of 270 at 30, try to get rid of some of this forward motion, switch over to storm relative velocity. And we can see in that convective cluster there, there's not really any couplets or anything like that. It's very kind of a subdued velocity field. And then, of course, we can take a look at the clear air velocity. We just look right around the Minneapolis area, and this is showing that we've got southwesterly winds through that area and very little directional turning. The zero line separating red from green is almost straight, and it's really when we have these S shapes, when we have curvature, that tells us that there's shear in the atmosphere. So, for example, if we, I don't know, maybe I can just pull up some severe weather. Why don't we do that, since we don't have much going on? Okay, so yeah, this is where I keep all my cases here. So maybe I can pull up the big Oklahoma outbreak. Oklahoma tornadoes, that's kind of a familiar one there. And let's pull that up for about 6 p.m. Okay, products are loading, and there's the velocity product, and the reflectivity looks like this. But let me break, this is kind of distorted a little bit by the convection, so I need to run this back even further. Let me go all the way back to about 5 p.m., maybe even a little further back. I'm sure some of you probably remember this day. This is when Norman had a tornado in the area. So those are those cells right there. Out to the west we can see the dry line. Again, this is historical data. This is not live. But here you can see in this area ahead of the storms, see there's no cells there. So this is really good for picking out the wind field, and we can see that curvature. That's what we look for on the clear air returns right there. And this is showing that basically near the ground the winds are out of the southeast, and then as we go higher away from the radar, the winds are more southwesterly. So that's that turning there with height that helps bring up the storm relative velocity and allows for streamwise vorticity to concentrate in the updraft and give us some rotating storms. Okay, so we're done with that. Let's move on to today's weather. Start out with the upper levels, and let me check in with chat, make sure the audio is going. Since we're about 10 minutes in, I don't want to go much further until I get that checked out. Audio is great. Okay, good, very good. Ron Chalfant saying Happy Father's Day. Same for Ryan Toomeys. Appreciate that. David Lumbert, 88/72 in Maumelle, Arkansas. Ryan watching the College World Series. Likes the drone footage. Yeah, I'm really getting some great video with that thing. Can't wait until we get some good Arcus cloud coming in from the west. That's going to be really spectacular. Erica Baker, 90/72 there in Kansas. Got Willie Greenway there in Georgia. Cthulhu, thank you for that, Cthulhu. Jeff Krob joining us, has been a while. Also Sue M joining us, and Bobby Conway, 79/70. Carl Berghoff says he had quite the line of storms this afternoon, was barely able to see a wall cloud by about 5 miles. Houston, Galveston, looking at heavy rainfall. Yeah, they're getting the brunt of that tropical flow coming in from the south. Michelle Curlin also joining us. Alexi Pinkson-Walsh. Jeff Krov reporting Go 17 team is trying to figure out the ABI thermal issues. There's been some problem with that new satellite there. David Moore also joining us. Michelle Curlin got some rain along the coast this morning. If Tim had seen the radar at Duluth around 4 to 5 p.m., he would have seen better organization. So I guess the storms are just kind of falling apart everywhere at this time. So 250 millibar chart showing that big ridge that we were talking about right there over Oklahoma. Looks like the axis is running about from about Abilene to Kansas City. And we've got this section here that's probably a subtropical jet coming in from the south. Very amplified pattern. And then off to the west, we've got that upper level trough over Oregon. We'll check in on the cap strength at 700 millibars, looking at the temperature here at 10,000 feet. Looks like some of the highest values are around Kansas right there. There's 11 to 12. And then, of course, in the higher terrain, we've got 11s in that area right there. Looks like 11 in Fort Worth. Yeah, I'm going to probably paint that somewhat like that right there. So those are the highest upper level temperatures. But along the periphery right here in East Texas, that's where we're getting some storms breaking out there. Take a look at the isobars and thickness. We can see that thermal gradient up to the north there, from Minnesota up to Manitoba. So there's the basic outline of the fronts, and it looks like we have another one there in Nevada. Okay, so that runs from Denver to Salt Lake City and down to Las Vegas. And that's being driven by this cool air extending from the Pacific Northwest up to Saskatchewan and Manitoba. So a pretty simple pattern, and there's what looks like outgoing high moving off the east coast right there, and the Bermuda high not particularly strong. We're looking at this entire area for the location of the Bermuda high, and I can see a little bit of ridging right there, but overall it looks like maybe a lot of the gradient there in Texas being driven by this troughing right in this area here. Okay, we'll check out the satellite, get the view from overhead. There's the water vapor. So that's showing some of the upper level moisture coming into Texas. A lot of what we're seeing on here is actually convective debris that gets lofted from the surface into the upper levels. So it's a combination of that convective debris and also the deeper tropical moisture down to the south that we're seeing here. So this is probably a little bit more of that thunderstorm remnants. Same thing up in the central plains right there. And then out to the west we can see the dry air coming into the southwestern U.S. right there. So bit of a change out there. We had Bud coming up the Gulf of California a couple days ago, and you can see that's pretty much gone. That's connected up to that frontal system in the Dakotas. Another way we can look at the patterns over the past day is to run the satellite back. So starting out today, this time of year, what I'm looking for is mesoscale convective systems. And it appears there's probably one up in northern Wisconsin right there. Area disturbed weather out there in the Gulf, about to move inland. So we'll run that forward. And you can focus on your area of interest there. Here in Texas, it's the tropical moisture we're watching. And then out to the west, lots of clouds with that trough moving across the Great Basin area, so combination of upper level cool air and very strong solar heating really helping things to destabilize. And you can see the spinning right there. Can pretty much pick out exactly where that upper level low is, and we can kind of track it And it looks like at this time it's in far southeastern Oregon near the Nevada border. We'll take a look at some specific areas of interest, starting with the northern plains. Many thunderstorms all up and down that front. And we'll run things back earlier today. And maybe I'll pause it. And yeah, definitely earlier today, uncapped. Lots of storms going up across southern Minnesota there. And then also in South Dakota and Nebraska, you can see down underneath these anvils, there's this area of stratus and stratocumulus indicating the frontal air mass. So that places the front just to the south of that. And you can actually see it right there. Combination of a front and outflow pool there in Nebraska. Not much else to say about Texas. I'll just run that through and you can see the showers moving inland and the storms up in the panhandles. Also some storms out there in Georgia and Alabama. Finish out that loop there. And I can see a few outflow boundaries there in Alabama. You can see it right there on that storm along the Alabama-Georgia border. See it right there. And it looks like it actually triggers that cell right there. So there's actually a lot to look at on these images. And of course we've got something even better than this. I've got the 1 minute data. This is a special mesoscale scan from the GOES-R satellites, and you can really see the overshooting tops and new cells going up and old cells collapsing there. We'll run that through one more time. So this is always spectacular to look at here. Okay, so that brings us to the forecast. Okay, starting out here in Texas. It's going to be kind of a rainy pattern. Things should shut down, give us a bit of a break overnight, but you can see a cluster of storms coming onshore there around Beaumont and Houston. That's going to be probably moving inland during the morning. And then as we get the heating starting up, especially to the north, outside of that debris cloud area, we should see a lot of cells start to go up right there. And that's just past the end of this runtime. So we'll take a look at that on the NAM. For the northern plains, these cells here along the Minnesota-Iowa border should form up into an MCS overnight. And then those will start dying off around dawn. But down in Nebraska, if I run that back, you can see this cluster. Yeah, right here around Grand Island, that goes up around 3 in the morning, and that's actually going to be forming up into a new MCS and moving across Iowa during the morning hours. So that'll have impacts there on Sioux City, and I don't know all the towns there in Nebraska. All right, so let's take a look at the upper level pattern, 250 millibars. And what we see here, starting out today, there's a high centered there over Kansas. So normally we would expect to see very hot temperatures throughout the column. That's usually what keeps convection shut down. But if we load up the skew-t's, we don't actually see a whole lot of warm air. In fact, the 700 millibar temperatures are only about 10 Celsius right there. That's not particularly high. So what's going on there? Well, if we go aloft, we do see some very warm air. And we're measuring 200 millibars. This is way up here. So that warm air has enough impact to be measured there, 200 millibars. But if we actually look at the 500 millibar level, we see a different picture. So no longer do we have that high pressure area right there. It's actually centered there in Tennessee. So the system actually has some slope along that axis right there. So 200 millibars, we find the high right there in Kansas, and then 500 over Tennessee. And just for fun, why don't we take a look at the 500 millibar, or I'm sorry, the Tennessee skew-t. This, go back to 200 millibars, and we run that forward. You can see that high move to the east there over the Midwest. So by tomorrow, it's going to be over Indiana, and during the afternoon, it's going to spread out towards Tennessee or Pennsylvania and West Virginia there, and they're going to be seeing some very hot temperatures in that part of the country. And just running this through the rest of the period. Bit of a polar front jet moving into Utah and Nevada, curving up to the Dakotas. So most of the impacts from that, from this wave right here, that'll affect mostly the Central Plains. And then Texas will get a little bit of the tail end right there. That, with the incoming moisture, should keep things wet for the state here. And then we can look at the precipitable water. That's really a big thing this time of year, especially with the system we have coming in Texas. All the water vapor, you get about an inch in the rain gauge. The darker purple is 1.5 inches. And then this lavender color, that's going to be about 2 inches precipitable water. So if we run this forward, you can see the flow of moisture coming into Texas, and ultimately that will feed the Central Plains over the next few days. So we've definitely got the moisture surging in, and that's going to affect pretty much everybody east of the Rockies and west of the Appalachians. So we'll go ahead and put that together. We'll just start out with Texas real quick and look at the weather tomorrow. So we'll have that system offshore. Some convergence along the coast, helping to generate some storms in that area. And then we get the convection going in Texas from diabatic heating. And it looks like a few bands form. Offshore area of Texas moves inland. And then things should start drying out a little bit around Wednesday going into Thursday. And taking a look elsewhere around the country. Got that front up to the north from Minnesota down to Colorado and again to Nevada. And we'll just kind of run this very quickly forward into Tuesday. Looks like that front will just kind of be stationary in Nebraska and Colorado. Some very warm weather on Monday for the Northeast. They're going to be kind of baking in that area. But cold front comes through on Tuesday, so that'll cool things down quite a bit. Wish we would have that happen here in Texas when we get a heat wave. We just tend to have weeks and weeks of hot weather here, but this year hasn't been too bad. Anyway, as I stated earlier, lots of convection there in the Central Plains. All that moisture feeding northward, and eventually it's going to reach that front up there, and we're going to have probably a few days of active weather in that part of the country. All that precip, of course, will reinforce the front. So we're going to see that front slipping southward finally. There it goes into northwest Texas. Yeah, it looks like a bit of a warm front there around St. Louis. This is on Thursday morning. And then by Friday, got a bit of a low pressure area there in Missouri, and probably a couple of stagnant boundaries right along these axes right here. So that'll probably be a focus for convection on Friday. And let's see, next big change, just a couple of MCSs in Nebraska over the weekend. Another boundary kind of sitting like that. This is on Monday the 25th. Looks like that boundary lifts northward with a strong southerly flow. Another front coming into the northwest right there. And of course that'll push mostly in. Looks like a very wet pattern there for the central plains. And then the model leads us into July. So we've already got panels for the July third period. And I don't see much going on. Looks like maybe a weak disturbance out in the Gulf, but this is probably a little bit too early to tell. And one thing that I want to do is do a run through of the precipitable water. Let's see what that's going to do. We already know that this is going to hit Texas and come up to that frontal boundary in the central U.S. But what's going to happen after that? Let's see. The next few days after that. Yeah, it looks like another moisture surge coming around the 27th and 28th into Texas. And that's about it right there. An eye on that. And let's go over to NHC and see if they've got anything going for the Atlantic. 5-day graphical tropical outlook. They got that system there in Texas. 20% chance of cyclone formation in 5 days. And it looks like a lot of that will be moving inland Monday and Tuesday. Okay, I think that's about all I got here. Let me take a look at the chat there. A few people getting a little buffering. Let me see how many frames we lost. Oh, good grief, yeah. Yeah, we're losing frames. All right, I'm going to sign off. All right, sorry about that. We will see you tomorrow. We'll try to get this cleared up. Until then, have a good evening. Thanks, guys.